Hey everyone! Welcome back to Syntax Grid, your go-to place for learning data science and machine learning in the simplest way possible. If you haven't already, make sure to check out Part 1 on Descriptive Statistics and Part 2 on Inferential Statistics, where we covered the foundations with real-world examples and Python implementations. In today's video, we're diving into advanced inferential statistics, covering T-tests, T-square tests, ANOVA, Type I and Type U errors. We'll understand what they are, when to use them, and how to implement them in Python. Let's get started. 1. Types of hypothesis tests. Concept. Hypothesis tests are statistical methods that help determine whether there is enough evidence in a sample to infer that a certain condition holds true for the entire population. Purpose. To test whether a claim about a population parameter holds true. Use case. Common in A/B testing, product comparison and treatment evaluations. Example 1. One-tailed T-test. We test if the sample mean is significantly greater than 65. This is a one-tailed hypothesis test. Example 2. Two-tailed T-test checks if the means of two independent groups are significantly different in either direction. 2. TTest concept. A t-test pairs the means of one or two groups to determine if they are significantly different from each other under the assumption that data is normally distributed. Purpose. To identify if the observed difference is statistically meaningful. Use case. Comparing test scores, product ratings, or performance before and after treatment. Example 1. One sample t-test tests if the sample mean differs from the population mean of 100. Example 2. Paired t-test evaluates if there's a significant difference in scores before and after an intervention. 3. Chi-square test. Concept. A chi-square test evaluates whether there is a significant association between categorical variables or whether observed data fits an expected distribution. Purpose. Test independence or goodness of fit in categorical data. Use case. Customer preferences, voting patterns, or brand affinity across regions. Example 1. Test of independence checks if two categorical variables, like product choice and region, are related. Example 2. Goodness of fit test tests whether observed frequencies differ from expected uniform distribution. 4. ANOVA, analysis of variance. ANOVA determines whether the means of three or more independent groups are significantly different from each other by comparing the variance between the groups to the variance within the groups. Purpose. To detect significant differences while controlling type I error. Use case. Comparing marketing strategies, regional sales, or treatments. Example 1. One-way ANOVA tests if there's a significant difference between three group means. Example 2. ANOVA using stats models compares average scores across three different teaching methods. 5. Type I and Type U errors. Concept. Type I error occurs when a true null hypothesis is rejected, false positive, while type Q error occurs when a false null hypothesis is not rejected, false negative. Both are critical in evaluating the reliability of hypothesis tests. Purpose. To understand and minimize risks in statistical testing. Use case. Critical in areas like medicine, fraud detection, and machine learning. Example 1. Type I error, false positive. Even if the null hypothesis is true, we might wrongly reject it due to chance. Example 2. Type 2 error, false negative. A true difference might go undetected if sample variance is high or sample size is low. And that wraps up our deep dive into advanced inferential statistics. We covered t-tests, chi-square tests, ANOVA, and the critical concept of type I and type II errors, all with practical Python examples. If you found this video helpful, don't forget to like, share, subscribe to Syntax Grid for more hands-on data science tutorials.